Yeah. Okay, so welcome for another Indeed session. Today, Roman will tell us a little bit about F#. I just want to tell you that we're also planning some general session on functional programming later this year. So it's nice that you are interested in F#. If you are more interested in functional programming in general, then hang on. We will have a session for you as well. So, okay, Roman, please feel free.
Okay, and maybe we should invite to next Smart, after next Smart, which will be about F#. I think it's on the 2nd of November.
Okay.
Yeah, and it will be special about F#. You will see something like you will see today, but because today I have only 30 minutes, so I will make something like floating on surface, but I hopefully give you all the information you came for. Hello again. My name is Provazník. I work here in CN Group. I'm here first or second month, so I'm quite newbie in here. I work here as F# developer. And today I would like to show you what the F# is and why should you even care. If you would be ever asked what the F# is, just remember three things. It's a multi-paradigm, strongly typed .NET language. You can have a look at this amazing logo. This is official logo, which is quite funny in Visegrad 4 countries, but other countries doesn't feel like it's phallic symbol for them, so it's okay. So this is really official logo. My friends, they told me that maybe the one reason I love F# is the logo itself. So it's not true. I love it for many reasons, and I will show you today the reasons why I really love this great language. F# first version was in May 2005. The whole language was designed by Don Syme. If you never heard about this guy, you probably would heard about him if you would go deep in history of C#, because he's the one who's responsible for adding generics into C#. So he's really smart guy. He's Australian and currently working in Microsoft Research. So why should you even care about F#? So reason number one, and I know many of you are not from .NET platform or .NET ecosystem, but first good thing is that it's .NET language. So if you are familiar with .NET, that's really great for you, because you can, for example, call F# code from C# and C# code from F#. So first big deal about F# is interoperability between C# and F#. So this is really great for you if you are familiar with this ecosystem. Second thing is that you can use your favorite editors. So if you know Visual Studio, go on, make some F#. If you know Visual Studio Code, no problem. You can also use Atom. You can use also Xamarin, because Xamarin was, I think, last year acquired by Microsoft. So right now, if you work on Mac, you can write your F# on Mac using Xamarin editor. Another good thing about F# for you, if you are from .NET world, is that you actually know the platform. So you can use your favorite nuggets, like, I don't know, Newtons of JSON and all those great stuff you already know. So everything you know from .NET, you don't need to throw it away to start with F#. So I think it's really good. And of course, there are a lot of known issues and fixes in whole .NET community. So this knowledge will really stay with you, and you don't have to throw it away. Second thing is that F# is multi-platform. So you can really develop your code like anywhere, on Windows, on Mac, even maybe on Linux, but I never tried. But I have own experience with developing on Windows and on Mac, and it's really great because, as said, you don't really need to take care about what platform you are on. Just go and type some code. If you like some compilers to JavaScript, I have good news for you. because there's a thing called Fable, which now has this great Fable.io hipster domain. And this allows you to write F# and compile it to JavaScript. Even like if it supports, or you can write like React Native apps and things like this. I'm not really into front end. I'm doing my best to avoid using JavaScript and all the things that smell with JavaScript. But if you would find this language interesting and you want to make front end, it's good to know that you can compile your F# to JavaScript. Third thing, which is really great, and I think it's great for you if you would start with F#, is that F# is multi-paradigm. This means that, you know, a lot of guys like OOP, only OOP. And some of us say, no, functional is better. It's much harder, but better. And F# say, okay, why not both, right? We can combine the paradigms. So you can take the best from both paradigms. You can create interfaces, abstract classes, inheritance, whatever you feel comfortable with in a C# and OOP world. And also, you can combine it with things like higher order functions, kerning, lambdas, whatever you like from functional programming. So really, if you want to start, it's really great that you can start writing code as you normally would, and then like step by step to transform from OOP to FP, and it's really natural because I'm the guy who used to work with C# a lot, mainly on web apps, and I found F# really easy to join in and to start writing. And then one day I decided, okay, that's enough, C#, bye. And this possibility to combine both paradigms it's really great. Many of you are from JVM world, so you know probably Scala. Scala, as far as I know, offers something similar. So I really recommend you to, if you want to start with functional programming, select some good language, or if you're from JVM, you can select also Clojure. But if you want to combine those paradigms, I think F# is really great. What is really good, and right now we are getting to point number 4, which will be for some of C# guys like Discutable, is that F# is easy to write because its syntax is based on OCaml. So it uses almost no brackets, no semicolons, and it's really easy to write because you get rid of a lot of like code smell and writing smell, and like where should be brackets after the declaration or next line, things like this. They're passed. You don't have to worry about it because this syntax is quite different, and it's really easy. If you have a look at this, I created a simple add function which has 2 parameters, x, epsilon, and then just something. That's all. That's like no brackets, nothing else. Like you focus on a solution. Just if you want to add 2 numbers, go on, write function for adding 2 numbers. There's nothing else you should do, like deciding where to put it, in which class, how to call it, where to stop it. This is much better. And if you want to call it a function, just do it and pass some parameters. That's all. That's really easy to read and easy to write. And maybe you notice one great thing which makes reading and writing F# mostly writing much easy. And this is that you don't need to specify any types. Just have a look, like, okay, I want to multiply this, and this returns 42. How is it possible? F# has a really great feature, which is called type inference. And it does just simple thing. It looks through all your code, and on the first usage of some function, decides what type of arguments should pass in. And it's still strongly typed, so you don't have to worry about some runtime exception based on some type juggling. All you need to do, just write your code. Sometimes, and it happens time to time, if you have really like specific code or too difficult, sometimes type inference told you, hey man, I cannot compile it because right now I'm not able to search through all your code, all the references, and find what the type should be. So please tell me. So you can specify type. I'll show you later how to specify type of the parameter, and then everything is okay. You can compile it, and it's still strongly typed. There's another great thing for writing F# code, which is called REPL. Guys from Clojure already know this. It's read, evaluate, print loop, which means that you write your code, you select some part of it, and you evaluate it right after, and you see the result, which is really great because it leads to many, okay, let's say side effects, but really nice side effects. First one is that your code is much more like to be testable because you create little parts, little code, which can be converted to unit tests. So it helps you with writing testable code. And of course, second thing is like debugger should, like from my point of view, debugger should stay for debugging. So you are not debugging when you are writing code. You are writing code and you want to see how it works. So that's something different. So REPL, it's great. And if you will start writing F#, all you need to do, just select your code, alt enter, and you can see the result. You can see the types, what's in there. All the pre-built types in F# have pretty print. So you don't need to like override two strings and things like this. Everything is already prepared for you. So this is really great thing. Another good thing that goes hand in point 4, it's point 5. It's easy to read. So how come is F# code easy to read? If you have a look at C#, on the right side, you can see like normal function, do something, call foo, put the bar, and zoo, and monkey. As you can see, this is against your natural feeling of reading text, because if you read not just English, the check is the same. You read from left to right, from top to bottom. But if you read your code, or code, for Christ's sake, for somebody else, you read it from right to left and from bottom to top. F# has a really great thing, which is called operator. There are plenty of them. And you can write your code at the very same way as you then later read it. So you have monkey, you pass it to function zoo, then do bar, then do foo. Using F# operators, it make code much readable, and it's really great if you go to GitHub, look at some open source library, and you right after you can have a look and know what's going on, because you can read it quite easily. It's really great. F# has many useful operators. I just wanted to show you 3 of them because they are the most usage. I think the most popular one is the pipe forward operator, which is really easy. It does nothing else, just it takes that the left side value and puts it as the last parameter of the function on the right side. That's it. So you could call this on line 3. You can call say hello Roman, and it's totally okay. Or you can say, okay, Roman, say hello. It sounds same, but it's really different thinking of code, because you just specify your parameters first and then to which function it goes. So it's really powerful. Also, sometimes you want, like, for example, you want to print the square of the 10 or some number. So if you want to print it, you should like evaluate this first and then put it as the last parameter to this function. So pipe backward operator is only because of like specifying the priority of execution of the code. But if you like would really remember one operator from this quite fast session, just remember pipe over operator. It's really, really mind-gapping thing in writing code. It's really, really great.
Is there somebody use the the operators with one way and some people use the second way, or it's
it depends. It depends on priority you want to run your code. But if you go through all the known F# code, I think from 95% you will find this one. It's typical way of writing code. And as said, sometimes you need like evaluate the right side and then put it to left side. If you would change the way, it wouldn't work, because it would like evaluate this first and put it to function square as a second parameter. So this is something different. And also, which is really great, and I wanted to show you, is forward composition. This is I don't want to talk about function composition right now, because we will have indeed about functional programming, like I think by the end of this year. But it's really great. Like composition of function is like Lego. You like one brick, second brick, third brick, and if those bricks can match together, you can create a new function only like putting them together. You don't need to write anything else. So if you have function for adding 10 to some numbers, okay, so you create a function for adding 10 to some number. That's definitely okay. Let's call it add 10. And then you can create new function, which is called add 10 and say hello, which is composition of adding 10, then convert it to string, and then say it to hello. So because this, like on input has integer, on output it has integer, string it has whatever on input, and on output goes string, and say hello, because you know this function already has string on input and string on output. So if you have a look at this signature is input is integer and output is string. It's really, I think it looks like strange, but it's really great, and it's really a really powerful thing. So remember those three operators. They're really great. Point number 6, why F# is great, and I think this is really important part, maybe the most important part, is number 6, that F# embraces safety. It brings immutable data structures like function types, records, discriminated unions, and there are a lot of them. Why they are important? Like again, about immutability, there will be next indeed only about functional programming. But just remember 3 things: that whenever it's immutable, it's easy to test, it's easy to parallelize, because like when you are not changing anything, there's no problem to run it like 10 times, 10 threads, no problem at all. And also immutability makes your code really much more predictable than like code with side effects and changing, mutating states and things like this. It's really nice. You cannot screw what you cannot change. This is like my, this is something, I don't know what I heard, but I use it in everywhere. So I'm not trying to change anything. So you just cannot screw it when it's immutable. It's really great. Second thing, it's state safety. There's really great quote that you should always make your code like illegal states unrepresentable. That's terrible word. So in F#, it's really easy. For example, you want to design something for counting tennis game. So in F#, if you have a look at this, you have this data structure is called discriminated union, and you know that if you have some software for counting tennis, you know that you have 2 players, A, B. They can have points 0, 15, 30, 40, and game can have only 4 states, like score of these points. It can be deuce. Oh, that's a mistake. Can be deuce only. There's no meaning to have player in here, so forget it. Deuce. Or advantage of player, or victory of player. So on 8 rows, including amazing comment, you can see that we design a tennis game which is absolutely safe. It cannot be like, I don't know, 45, 78, 76. All you need to do is implement like transition from one state to another. So that's really, really great thing.
Isn't the juice part of the first line? Because juice is 40-40.
Juice is 40-40, but it has different, when you are in juice and you win the point, you get to advantage. So it's different state.
Yeah, but still 40-40 is the first case. So one case is in 40-40 and juice.
Okay, maybe we could like make only score, advantage and victory, but juice has special rules for even when you win the ball, because you cannot go from deuce to victory with not having advantage.
Yeah, or maybe exclude the 40-40 from the first case.
Okay, that's correct. Or just get rid of 40. Yeah, that's good point. Exactly, great. So if you know how to write it, not just like me, F# makes illegal states unrepresentable, which is really, really great thing. And speaking about safety, F# has no null. That's really, really great thing. So yeah, no null. I love it. So let's have some dance, okay? No, I really, really love the feeling of safety, because I hate null. I think everyone who ever got like null reference or null pointer exception in Java world, it's terrible mistake. It's called $1 billion mistake, and I think null is terrible thing. Okay, so how to define that sometimes you don't have a value? So great, good that you asked. It's option. It's called the option type, which is, if you would go deeper, it's only discriminated union having like two states. First state is there's nothing, which is called none, or there's something of type, which is generic. So, for example, if I want to print integer and I don't know if I will ever get that integer, so I say, okay, my function can print integer, but I don't expect you will pass me all the time. So if you will pass none, I say, sorry, I have no number, go home, I cannot print anything else. And if it's sum, it means that you pass some value. Okay, you can extract. This is called, this thing is called pattern matching. It's really, really powerful, but we will talk about pattern matching on next mark. And you can take this value, like extract it, and use it in this part, so you can directly print it. Sorry. So this is really great. Like having no null, it's amazing for you when you're writing code. It's great, and it goes with the feeling that you make legal state unrepresentable. That's like going hand in hand. Okay, again. Right. So, and the last one, I don't know what's the time, maybe. Oh, okay. It's number 7, which is something you should always have when you are working on some technology which should be in business in next 2 decades. So, F# is a really great community. There are a lot of libraries, like for anything you can decide, like if you want to go to JavaScript, if you want to develop web application, if you want some cloud-based things, I don't know, it depends on you. There's package or library for everything. We don't call them frameworks, because I would really recommend you to see nice presentation from Tomáš Petříček, who is the most famous F# guy, and he's also Czech. His speak about what's the difference between library and framework is really good. So there are a lot of F# libraries. Also, there are some user groups. So it depends on you. I don't know if you are broadcasting right now to Romania, if there are any user group. But if you list the community on community.f#.org, you will find if there's any. We have. I created the Czech F# community, which is the first in Middle Europe, right? And so feel free to join us. And next next Wednesday, we will have in 6 days, we will have next meetup, so feel free to join. And also, there are Slack channels we can discuss like coding problems and then library problems and or solutions of whatever is going on in F# world. It's discussed on fsharp.com or our Czech Slack. So if you want to start, if you right now feel like, okay, I'm from Java world, but this sounds a little bit interesting, so that's good. You can go to fsharp.org. You should definitely have a look at website which is called F# for Fun and Profit. It's like F# Bible. It's something that you must read. It's great. And also you can go to tryfsharp.org when you have like some online learning tutorials. You're starting with little easy functions like adding two numbers, and you end up with some pipes and things like this. So it's really good. So to sum it up, F# is multi-paradigm, multi-platform. It's a .NET language which embraces safety. It's easy to read and write, and having great community. So this is the reason why I love it, why I decided to be my first and hopefully the only language for some time. This is the message I wanted to tell you in this 30 minutes. So thank you for listening me. And feel free to ask if you have any question. I don't know. I know Mireček already asked, so he's out. So
If you can go back to the last example, and we are so happy about not having null. Yes.
Yes.
So what happens if you don't cover the none option? If you don't.
Great question. Great question. Yeah. There are two things that happen. First one is we have really smart compiler, and compiler will throw in a warning and say, "Hey man, are you crazy? You didn't like check the none. What will happen?" So you go and fix it, or you just say, "Okay, I'm too brave to do it. I don't care." And if you pass here none, there's unhandled option. Unmatched option exception, something like this. It throws an exception, runtime exception.
If the content of the function was just printf number was %i, what would happen if I call it with
Completely remove the match now.
yeah.
Just use the first line of the code.
If you use the first line of the code,
Yeah, without the sum, just the n print f.
no, it won't match. It won't let you even compile, because right now, if you
use everything and let the printf number n, just that.
Without matching.
Without matching, it won't let you, because you set in here it's integer, and this is not integer. This is sum of integer. So you can do things. It's like nullable in C#. You can go n dot value, but the same. If you ask for dot value for non-type, you get a runtime exception. So you can do it, but don't do it.
So what's the profit if you anyway have to write a code which covers something like null value?
You cannot pass now.
You cannot pass null. You can pass null in here. You can never pass like call print int with null. You cannot do this. You can. It won't even compile. Like say you can't. You can only pass some or none. Some with some value or none. That's all. And none. It's not null. It's one case. One case of the two possible cases of option, which is I have something, I don't have anything.
So if somebody is stupid enough to don't check null in the C# or Java or whatever, then somebody could do the same in F#, technically.
You cannot put none into variable.
You can.
You cannot here. How?
Like
You cannot call the print in with x, which would be now.
Yeah, you cannot even call it. I'll try to do it. I think to call this from C#, you would have to pass special type, I think, which is called F# option with some value. So you cannot call it a null. You cannot. Like but I will try to be 100% sure to call this from C#. But if you stay in F# role, there's no way how to pass null in here. So the only way how you can screw this up is that you like don't handle all the options that can happen in here. So in here you have only 2 options. But if you would like go back and, for example, you will pass a game, you need to handle all 4. And now it looks quite restrictive, but the truth is that it's really great because every time you get something in your function, you need to think about what it can cost. So you can like put underscore, which means that it handles all the states, and then you do something which is like shared result for all the values. But once you decide to handle one of them, you need to do it. It's called pattern matching. I really like go. Please come on next smart. We'll be speaking in Czech, so it will be for me much easier to explain. And I'll show you like how much pattern matching works and when it's good and when to use underscore and when not. So but for now, just stay with that in F# role, calling F# code from F#. You cannot put null in there. You cannot. You can only forget to handle some case, and that can lead to exception on runtime. But compilers warning you all the time and very loudly, like, hey man, this can happen, don't do it, handle this state somehow. Okay, so that's it.
How do they handle mixing the paradigms? I mean, like objective programming, which is mutable, and functional programming that should be safe and immutable.
Yeah, there is some keyword I didn't show you on purpose, which is called mutable. So all the values are immutable. But if you want to change, if really change like in variable old style way, you can define that it's mutable. Let mutable something equals string, and then you can like write new values into it. But it's great that it has special keywords. So every time you have a look at code, say, something is smelly here because I need to change the state. So that's okay. I did it, and I do it sometimes when for some performance reasons, I use mutable states, but they're only located and they don't like can go out of function. And I think also mutable value cannot leave the function scope, so or its own scope. So you cannot like return from function mutable value. So you can do it. So you can for example, if you implement some interface and it has to have setters, it can have setters and it must be defined as a mutable. So it can be no problem, but you are all the time, the language is like throwing rocks against you, like don't do it in different way, do it immutable, this is much easier, do it. So, but you can like write in old style, no problem.
So if you have like function that takes some OOP object, you have to always mark it as mutable, or?
You don't have to mark it as a mutable, but if this is, I think if it's from C# object and it has some mutable, like it has some property setters, you can set it and then you can like call it. It's no problem with that. So, but if you would like to define your own mutable value, it has different restrictions as far as I know.
So general idea about the null about to forcing you to use immutable classes, objects, is that you have to fight with the language to do it the way you shouldn't. And then after some times, even if you are very resistant, you will do it correctly.
Yeah, like you can do it quite easily, but you do it in sharp, you feel like inappropriate at doing like, okay, maybe it could be something different. So yeah, you can do it, but as you said, the language like tries to push you into immutable world. So
yeah.
Okay, So I will, if you are interested in, I will send you the link to this presentation to some GitHub, and also you can click through the links and have a look if you want. So I think Martin will send it to you over email. Okay.
You show us some real life code.
Yeah, real life code. Okay. So. Okay, so for example, right now we are automating. This is only test. This is good thing. This is something I can show you how to. Oh yeah, I should definitely make it bigger. Is better? Okay. So, for example, this is the way how we write test, and because there's application called STA automation, which is for Stena, and they have WPF application like Stena Travel Admin. It's called, I don't know, and I wrote a tool for QA guys to like make test automation instead of manual clicking. So. Good thing, for example, in F# is that if you want like your test call somehow, you can use this syntax. So you use to, I don't know what's apostrophe or tick, and you can write your name whenever you want, and you see it in your test result. So you can read your test like really an easy way. And for example. We can have a look. Okay, let's have a look at elements where we can. So here, for example, you can see that I created something like a class. It's called type, but if you put it, it's class that is called file. It wants a special search function on input, and use this function, as you can, fn, in when you call those members. So for example, if you want to search in tree of automation elements by automation ID, you put this ID, and you call this function, which is like search function, and the second parameter is something that returns sec is enumerable. It's collection of automation elements. But I don't want.
May I ask you?
Yeah.
I would like to know why we are talking about functional programming, because from my perspective, is F# just another type for writing the code as C# is, because you have there something like classes, you have there something like functions.
Yeah.
Why F# is functional programming? What does it mean, functional programming?
Yeah, that's funny. Definition of the functional programming. For me, functional programming is to not avoid of side effects, because you can actually avoid of side effects. But for me, functional programming is to localize and isolate side effects. And F# is really great in this because it goes like hand in hand with immutability, and this is like side effect is nothing else than the unexpected mutable. Yeah, mutable action. Why we call it functional programming? Because first of all, you always start with function, like having the type like object, which is fine. It's the end of many iterations when I decided, okay, I want to share some structure, and I only want to pass a function for searching, but all the rest will be exactly the same. And the reason why I decided is because you can see if I want to find wide, search, find deep, different search. It's only because I want to call it somewhere else, and by the end it will be called by guys from QA automation who are not who are not developers. They want like easy tasks to write tests, like click here, asset here. So I need to take care of their writing. I could use, for example, partial function application, which I use in course, but I cannot like teach them what is partial function application and all the things that you can do, like composing the functions, like high order functions. For example, as I said, I didn't show you a lot of things. For example, having high order function, it's really amazing thing you can do in F#. I never did it in C#. I would never try. And this is something which is right now for me only about functional programming, like having function which takes function and returns different function which you can call whenever you decide. You can work. That's another great thing. You can work with function as a value. So if I would say one thing, is this one. You can work with function as a value. So that's, you can pass it, you can split it, you can do whatever you want, and still function. So this is why I found F# much better and much different than C#. I maybe didn't show you the right project because right now I'm working on it, but there are a lot of code from C# that I use, like a whole automation element with this object, so you can call it on toString and things like this. So it's a library from Microsoft for automation of WPF applications. But for example, this is how real code looks like. You can find this ST automation on local TFS. So I can send you a link and you can have a look at this and go through and see the code. So it's open for all of you who has access to intranet. So I'm not like hiding my code, so you can go and have a look. So. Okay, anybody else? Okay, so thank you.
Good job.
Nepoužíváš link?
Cože?
Nepoužíváš link?